All right, in this video we are going to look at another skill with radicals, and that skill is to convert between exponential form and radical form. First, we must know the rule. The rule is that if you see a base raised to a fraction, like we do here, you can rewrite it in radical form. So follow the arrow this way, and the denominator of the fraction becomes the root. The numerator of the fraction becomes the exponent on the inside. There are basically two steps to follow as long as you know the rule. Step 1, label the exponent and label the root. Well, it looks like we're currently on this side of our conversion rule, so I'm going to label the numerator exponent and the denominator root. Okay, we need to go from the left side to the right side. So let's do that. I need to make a radical symbol. I need to put x underneath because that's the base we're using. And then I just have to put the exponent and the root in the correct location. 5 is the exponent according to what I labeled, so 5 goes there, and 6 is the root. These two are equivalent to each other. X to the 5/6 is the same as saying the 6th root of x to the 5th. Okay, let's do another one. I know sometimes you look at one and it's not enough, so let's do another one. All right, here we go. New problem. Okay, here's another one. It says write the expression in radical form. We're starting out in exponential form, and we need to go to radical form. So let's just match it up to our rule. It looks like we're starting on this side again. Let's do it in this color. We're starting on this side and we're going to this side. Okay? All right, so we gotta just do some labeling. Step 1, label the exponent and label the root. Top is the exponent, bottom is the root. Now we're on to step 2, convert. Make a radical symbol. If you're going to radical form, it's best to make a radical symbol. It might jog your memory as to what comes next. The base was x, so that goes on the inside. We labeled the numerator exponent, and that was 4. We labeled the denominator root, and the root always goes right there. And that was 7. So that's it, we're done. X to the 4th sevenths is equivalent to the 7th root of x to the 4th. I want to look at one more that's like that. All right, here's another one I want to look at, and the reason I want to look at this one is because sometimes we leave numbers out because they are implied. So here's an example of where we're going to leave a number out. Step 1, label the exponent and the root. So the numerator is 1, it's the exponent. The denominator is 6, it's the root. If we were to convert that, that would become make a root symbol, x underneath because that's the base. The exponent is 1 and the root is 6. But when the exponent is 1, you really don't need to write that. So if you notice that the exponent is 1, just change it so that the exponent is not visible, because typically in math we don't actually show it. But now we know that x to the 1/6 is the same as the 6th root of x. That same process that I just did also happens when there's a 2 in the denominator's place. So I'm going to find a problem like that and show it to you. All right, last example. In this one, we're going to do step 1, label exponent and root. We need to go to radical form, so I'm going to draw a radical. Our base is x. The exponent is 5, that goes in that position. And here, the root is 2. This is another case where you don't need to write a certain number because it's implied. Which one do you think is implied, the 2 or the 5? Hopefully you said the 2. Yeah, you never need to write the 2 in that position because when we talk about square roots, it's implied that there's a 2 there. So a couple things to remember is when you have a square root, there's an implied 2 here. And when you have a variable but you don't see an exponent, it's an implied 1. Other than that, they're going to put the numbers. So if you ever don't see a number, in the root position, it's a 2, and if it's in the power position or the exponent position, it's a 1. Other than that, they will show you the number. Let's take a look at what it would look like if we had to go the other way. We've been going from the fraction to the radical. Let's go the other way. Here's a perfect example right here. In this example, we have to write the expression in exponential form. We're starting on this side of our conversion, and we're going this way. It's okay, same steps. You just have to know where the pieces are. So we're going to label the exponent. If it's in this position or this form, the exponent is on the inside, and the root is on the outside. Okay, now we're going to write our base. We have to make a fraction. In the fraction, you got to be careful. Exponent goes on top, and if you forget, have this in your notes. Have this rule in your notes so you know. Exponent goes on top, so 2 goes on top, and 7 goes on the bottom. I don't need to not write anything here or omit anything because there's nothing understood about this. This is just x to the 2/7. Okay, one more example of that, and then I'm going to release you to try some on your own. All right, team, here's another example. First, let's make sure we understand what form. Oh, this is not a good one. Hold on. I want to go from radical form. Yeah, let's go with this one. We want to go from radical form, which is the right side of our conversion, to exponential form. All right, so first thing we need to do is step 1, label the exponent and the root. Here's a case where you're not going to see the exponent, but you know it's an understood 1. So I'm going to draw a little 1, and I'm going to label it exp for exponent. And on the outside, we have the root. Step 2, convert. What are we converting to? We're converting to a base with a fraction exponent. So let's kind of set it up. If we forget, we go back to this to look as a reference. The exponent goes in the numerator and the root goes in the denominator. If you did not know that there was a 1 there, then you would be confused as to what to put in the numerator. So make sure that you're actually drawing the 1 out if the exponent is a 1. And that's it. The 7th root of x is the same as x to the 1/7. Hope that helps.